Welcome to our presentation about our Spring 2021 Capstone project, Thunder CTF, Cloud Security Audit and Incidents Response. My name is Ashlyn Okamoto, and our team lead is Austen Nelson. Other team members include Janosch Achenbach, Mark Garvey, Michael Fiddes, Ruby Diehl, and Timothy Ivanishchuk. Our sponsor is Professor Wu Chang Feng, and faculty advisor is Professor Bruce Irvin.
Ruby here. Every week, it seems like there is a new data leak or ransom situation in the tech industry. Historically, we don't have a good track record when it comes to security. Part of the reason for these shortcomings is that security is a difficult problem to solve, especially as our systems continue to grow in complexity. On top of this, many industries are currently moving their infrastructures to cloud-based systems. For most organizations, renting cloud services is much more realistic than owning and maintaining hardware and software resources yourself. Scalability is also trivialized using the cloud compared to using in-house resources. Because of these reasons, it is likely that this migration to the cloud will continue without significant advances in edge computing. Students of CS or anyone interested in deploying cloud systems for their project or company should have some understanding of cloud security concepts. Currently, there are fairly limited resources available for learning about these topics, especially using the Google Cloud Project.
This is Janosch speaking. The goal of this project was to create one of those resources by creating a Codelab exercise, which could be used as part of a college-level course. Specific topics that the student or user will be exposed to during the completion of the Codelab include IAM or Identity and Access Management, iterative querying of cloud logs, steps of the incident response, and basic usage of cloud tech stack and resources. This Codelab provides introductory exposure to these topics by presenting the user with several cloud security situations to analyze and solve.
To give students experience working in a cloud environment, we had to deploy a cloud system for them to work in. And to deploy this system, we used an existing framework created by Nicholas Springer called Thunder CTF. This framework provides a small amount of abstraction over certain heavily used cloud APIs, as well as providing a lightweight CLI for setting up a code lab. Our initialization script uses the Google Cloud Deployment Manager, which allows automatic deployment of resources using resource templates to deploy our cloud system. And our cloud system includes resources such as Cloud SQL, service accounts, custom and predefined IAM policies, containerized compute engines, serverless cloud functions, and storage buckets. The system is set up in a way that contains vulnerabilities that allow escalation of privileges. After deploying the system, these vulnerabilities are exploited through another script, ultimately exfiltrating data and taking control of certain resources. The code lab will guide the user through the forensic process of determining what went wrong and what needs to be done to remediate the issues.
Hello, this is Mark, and next we're going to be talking about the system architecture. The system we set up provides some functionalities that might be included in various social media applications. First, there is a database that has relations for user information, user-to-user relationships like follows, and user content like statuses. To interact with this database, there is an API running on a containerized cloud compute instance. The compute instance is running a Docker image created by a Docker file along with other source code that are stored as a Git repository inside a storage bucket. Only developer service accounts have access to this bucket. A cloud function has been set up that can be used by developers to remove users from the platform. There are also various levels of service accounts with different privileges to the system resources. Almost all resources and accounts have their actions logged to a logging service where only one service account has been given read permissions.
Hello, my name is Michael, and I worked with Austen on putting together the design for the levels in this project. During the process of playing through these levels, the user will be investigating and remediating an automated exploit. Right now, I plan to talk a bit in detail about what that exploit actually entails, and then I'm going to show a quick demo of what a user might be expected to do while playing these levels and auditing the system. The exploit begins with the fictitious attacker starting with control of a service account that has access to view system logs. Leveraging that access, the attacker is able to sift through the system logs until they find an instance of a developer account attempting to invoke a cloud function, but accidentally passing sensitive key information to that function. That key information is logged, and the attacker is able to view that log and then elevate their privileges to the developer level. With the developer account, the attacker is then able to access a bucket containing the source code for the container that runs the API that manages interactions with the database for the system. In this bucket, there's also a key file for a compute admin account intended to provide the developers with easy access to everything they need to update the VM instance that is running the API. The compute admin privileges give the attacker the ability to adjust the VM instance metadata to replace the container image, thereby changing the source code that the VM is running. And since the attacker has access to the original source code for the VM, they are able to add their own code to the API without actually affecting the functionality of the system. In the case of this exploit, the code that the attacker adds to the API will take any SQL query as an argument and then execute it on the database for the system, and then returns the results in an HTTP response. The hacker uses this API endpoint that they've added to post nefarious statuses to some popular accounts and steal all of the user information in the database. As somebody taking the role of an auditor for this system, the users playing these levels will be initially given the information that these nefarious statuses are being posted and that there has been a breach, and then the user will have to work backwards through this exploit to figure out exactly how this happened. So now I'm going to take you through a small portion of the first level to give you an idea of how a user might experience this product. Alright, so as you can see here, I have already deployed the system. That takes a little bit of time, so 11 minutes this time. So when the system deploys, we'll have a starting message here for the user. And this one is telling us that statuses are being posted by accounts without the owner's knowledge. We need to find out how this is happening. And then to go with all the levels, we have a hint system in place that'll kind of walk the user through. So you will be introduced to these security concepts if you were having a hard time figuring stuff out on your own. These hints will introduce you to those concepts and kind of walk you through the steps of how to get towards the final conclusion of the levels. So our first hint is telling us that we should navigate to the compute instances page of the console. So I'm going to do that real quick here and let that load. And the reasoning that they give is that within the system diagram, statuses are stored within a table in the database, and then communication with the database will have to go through the API engine. And so if posts are being made without the actual owners of the accounts making those posts, then we know that something's happening through the API engine making posts to the database. So that's why we're looking at the API engine first. And then the next hint is telling us that we need to SSH into the API engine. So I'm going to get that going. And then by SSHing into here, we'll be able to investigate the actual VM instance and see what it's running. And we're going to actually look at the specific code that it's running as well. And then the hints will walk you through all that as well right here. So we're going to do a quick docker container ls to see our image here, and we can see that this is labeled compromised, which tells us this is probably not the right image that we want to be running on our VM, so that's probably part of the attack. Our next step here is we're actually going to open up a shell in that image, and we're going to observe the code for this image. So we're going to do this real quick. And of course, again, oh, I messed up a moment. Oh, of course. One moment. There we go. All right. And of course, if I looked at the hints, I would have known I should put a slash before the bin and not after the shell. But in any case, our next step here is to just do a cat main.py. This should show us the source code that the VM is running. And we see this is a Flask app. And we have these different methods here that we can hit, these different endpoints for following, for deleting, adding new users. But at the bottom here, we do see an endpoint called hacked. And if we look at what the code is doing, we see that it is just taking any SQL argument and making a request, posting it to the database. And so this kind of is telling us exactly how those posts are being made. And then the rest of the level will then take you through the steps of, you can see here, going through the logs explorer and investigating further into how this is happening, But that kind of gives you an idea of the kind of things that we want to show users, kind of teaching them how they can investigate a problem and giving them an intuition for where they should start to investigate those problems.
Ruby here. Our development process included meeting most weeks during the 2 terms, where about half of the members would give a quick update on their progress each week. The early meetings were mostly just group discussions to determine everyone's strengths and interests. When tasks were completed, new tasks could be assigned. However, most of the coding tasks were highly coupled. As a result, most of the system and exploit development was done in group or pair programming sessions. Even though only one person is usually working at a time during these sessions, we found working in groups like this helped stay on task and made it easier to address problems when they presented. We originally planned to use Agile or Kanban methods to organize the progress, but things usually moved along nicely without a super rigid structure. In hindsight, better utilization of some organizational method would have been quite useful, but most of our focus was spent getting our footing in the topic at hand.
This is Janosch speaking. Getting going with the project was a little bit of a challenge since for most of the group members, this was their first exposure to cloud systems and resources. Learning about what resources are available and how they are used was the first step for most of the team members. Mark and Ashlyn both had some experience with cloud systems and were able to help get the rest of the team up to speed. After getting some fundamentals, everyone went on to study different vulnerabilities and concepts we could include into the code lab. This was probably the most difficult part of the entire process because our sponsor gave us a lot of freedom in what the requirements were. We eventually decided to set up some resources that would provide some very primitive Twitter-like functionality and design the exploit to move through those resources. This next stage of the project was spending weeks trying to get these resources deployed and working together in the system. During this process, we had some idea of what kind of vulnerabilities we wanted to include in the system, but didn't have exact plans of where they would fit in. Once all the resources were set up, they were adjusted to allow for a chain of different exploits. After the vulnerable system was in place, we had to script the actual exploit process. This turned out to be more challenging than expected because of difference in the G-Cloud console, G-Cloud CLI, resource APIs, and Python libraries. For consistency, we wanted to mostly use the Python discovery module for the exploit, but certain actions were only available through other means. Once the system setup and exploit were all automated, all that remained was creating the documentation, instructions, interface, and this presentation.
We could probably do an entire presentation on only the difficulties we encountered, but here are some of the ones that stand out from memory. First of all, there are bugs in the Google Cloud Platform. When we first experienced weird behavior, we kind of assumed that it was our fault and that we were using the tech incorrectly. When it kept happening and we discovered similar issues on GitHub or Google Forums with little explanation, we started to realize that some things are just completely broken. Sometimes it was an error that didn't make sense or was inconsistent, and others would be an API calls that never completed. So occasionally the console would fail to load some details about certain resources, but querying using the Google Cloud SDK worked just fine. When working with unfamiliar tech, this sort of thing can be incredibly frustrating, and we definitely didn't expect this level of inconsistency from such a large product from Google. Another issue we ran into is there are 1,000 ways to do pretty much everything, so this makes organizing and searching documentation quite difficult. But the benefit is, at least if one method didn't work, there's always another to try to get more insight. A lot of the documentation provided by Google on the resources and APIs is quite good. However, for some reason, for some of the Python libraries, it wasn't as great at all. So as a result, the development process included a lot of experimentation, which kind of leads into the next issue. The development process could be fairly painful at times. Because of the poor documentation, limitations of Python static analysis tools, development was very iterative. So we would make a few changes, then deploy to see if it fixed the error or did what we wanted it to do. And unfortunately for us, deploying and cleaning up the resources could take anywhere from 2 to 10 minutes each time. When there were multiple errors to fix, this means about a half hour of work could result in limited tangible progress, which sucked, to put it plainly. At a certain point early in the development of the system, we had some plans to do an exploit relating to permissions to the database. Since we were using the specific Google Cloud SQL MySQL product, we found that the ways to interact with the database were extremely limited as a security precaution. This realization basically took us back to the drawing board for part of the exploit and vulnerability design, as well as limited how we could implement the system. Many of the error messages were quite generic or lacking in detail, and anyone who has done work in Python knows how useful the crash tag traces are. Lastly, we were working with many new tools. Working with 1 or 2 new tools slows things down enough, but when your entire collection of tools is unfamiliar, it could definitely be overwhelming at times.
Hi, this is Ashlyn. We met with our sponsor, Professor Wu Chang Feng, once or twice a month throughout the project. The original proposal was fairly open-ended, which allowed a lot of agency for us to decide which direction to take it. During our meetings with Professor Feng, we got to discuss ideas and related topics. He also provided us with research materials and resources. At the end of the project, he was satisfied with how it shaped up, even though we accomplished less than the original plan. It sounds like something he's excited to integrate into his course curriculum.
In the end, we gained knowledge and experience with the Google Cloud Platform, cloud security best practices, and common pitfalls that are associated with using cloud platforms. There was many ways to build this project, and naturally the system went through several iterations during development, as we found out some services were not viable or were restricted due to security reasons set in place by GCP. Lastly, we did our best at maintaining a Git repository. Although we tried our best following proper branching practices, we ended up working off a single branch. In the future, following better Git practices is wanted.
Alright, that's all we have for you today. I hope you've enjoyed our presentation and maybe you're feeling inspired to learn about some computer security now. I'm Austen and I was lucky enough to be the team lead for this great group over the last 2 terms working on this project. This was easily the smoothest group project I've ever participated in, which was a really surprising coming from that we're doing a 7-person, 20-week-long project with no one you've ever met before while maintaining social distancing. So all in all, it was a great experience. I wish I could have been a better lead right off the start. I didn't realize going into this how difficult it was going to be to delegate tasks and organize everyone's actions. We had good intentions for the Git hygiene at the start, but it didn't last very long, so it's unfortunate. The most challenging part of the project for me was telling people what to do early on when I wasn't even really sure where the project was going to go or how it was going to shape up. It was a little bit scary for a minute, but we came through. All around, I had a great experience, and I can say with confidence that my team did as well. I know that they will all be successful in whatever comes next, and to any upcoming seniors starting Capstone, I suggest taking this special class as an opportunity to step out of your comfort zone. On top of my team, I'd like to thank Professor Wu Chang Feng, our faculty advisor, Professor Bruce Irvin, the wise Capstone shepherd, Wen for showing us another perspective of the framework, and even though I never met Nicholas, thank you, Nicholas, for giving us a place to start with this project. We would have been quite lost without you. Thanks again for watching, and hope you have a good one.